All right. Okay, guys, you have to do 1A, B, 4A, and B, and then 5 and 6. Okay, right? Is that correct? Okay, so for 1A, you obviously didn't have to draw the pictures, guys. I just like having them make you know what's there. We agree that that's the rectangular prism. Right, so the base is the rectangle. Right, the base is this rectangle here, which I will just color in quickly so that you can see. The base is that rectangle there, which is like on the bottom, which we actually can't see, but they have put those dotted lines there so that we can tell that that is the base. All right. So we need to find the area of this rectangle on the base and then multiply by the height of the box, which is 6. Okay. Some of you were asking me on Monday, I think. Yeah, on Monday. If you have to write the formula, guys, you don't have to. Okay, you can go straight into just doing the values that you're multiplying. But this is the area of the base, right? The length times breadth. The 29 times 13, and then you times that by the height of the box. Yes. Yeah, it's something you're not forward, the value is one side and one side. If it's a more complicated one where you first have to calculate the side and stuff. Okay, are we fine with that one, guys? Oh, B, I didn't draw in dotted lines. Were there dotted lines in the book? Okay, let me just check quickly. Sorry. So let me do the dot. Oh, now if I do the dots, then I'm gonna have to erase. Okay, I'll just do like a thin line instead of a dotted line. Sorry, I can't do dots now. Okay, there we go. That one there at the bottom now. Oh, sorry. That one is the base, right? Now, guys, some of you were getting confused the other day. You were thinking that because these two sides are equal, that this is now no longer a rectangular prism, and that it might be a cube. Guys, a cube is very specifically every single side has to be the same length. Yes. Okay. Yeah, I can't remember what we said in the book. Yeah, that should be all right. But if you have any of your faces, remember we have 6 faces all around, right? Every single literally face of this this prism is a shape. But if some of your faces are rectangles, then it is a rectangular prism. Okay. Do we agree that this face over here is actually going to be a square? The one on the side is a square, and that one is a square. But the other 4 are all rectangles, guys. As soon as you have any rectangular faces, then it counts as a rectangular prism. All right. So the area of this base is 15 times 6.5, and then you must multiply it by the height of the box, which is also 6.5. Okay. And then you get your answer there. Please remember your millimeters cubed, right? If you're just leaving it as the value, you're going to lose the mark. You have to put the units. Okay, for area and perimeter and volume surface area, they give marks for the units. So make sure that you did write millimeters cubed for this one. Okay, any questions on the rectangular prism question? Right, let's look at the triangular prism. All right, so there we have a triangular prism, guys. You see that this one and the next one actually they were not drawn standing on the base. Yes. Awesome. So you work the same meters. Yeah, that's fine. What was your answer then? 45? 4,5. That's fine, yeah. And then it would have been 20 I don't think they specified in this question. Just double check. But they say it is around units. Oh, okay, yeah. So then it's fine if you work with centimeters instead. Now, guys, even though this box is not standing on the triangle, we know that if it is a triangular prism, then the triangle does count as the base of this prism. Almost a prism. All right, so that would be the base thing, right? So you do half base of the base, right? Base of the triangle, which is 144, times perpendicular height. Did we notice that the units were different? Okay, so what I did was I changed 2.5 centimeters to 25 millimeters. But like Tyler was asking, you could have gone to centimeters instead. And then, guys, the height of the actual box. Now, some of you will quite confused because it doesn't look like a height here. Hey, the height of the box looks like it's this. But guys, if you are confused and if you're not sure of what the height of the box is, it's always the distance between the two triangles. So maybe we should add that in a note somewhere, right? The height of the box here, sometimes it's confusing. If you don't want to think about height of the box necessarily in that way, then you can think of distance between the triangles. All right, that in some cases will actually be easier to see what that is. All right, so if we're looking at, we have a triangle here in front and we have a triangle at the back, and the distance between the triangles is that 2.5 centimeters. Okay. Just in case the height is confusing you there. Any questions on this one? Okay, the next one was a right angle triangle, but the method is still the same, guys. Again, it's not drawn standing on the triangle, but it still is the base, all right? So the triangle is still the base of this prism, so we need to find the area of this triangle, which is half 4.2 times perpendicular height, which is 2.1. And then, guys, what is the distance between the two triangles? 3.7. Okay, so that is the height of the actual box. If it was standing on the triangle, that would be the height of the box. For this one, they were all given in centimeters, so I think you would have left it as centimeters. Why did I round this now to 3 decimals? What did they say? Just check. Oh, they just said calculate the volume. Okay, so guys, if you wrote this as 16,32, that's the fine. Or maybe even 16,3. Normally in test Tuesday, you must round to 2 decimals. Okay, let's look at number 5. Number 5 was a bit of a problem-solving question because they didn't tell you exactly this is your prism and these are the dimensions, find the volume, right? So I wrote the question down, which you obviously didn't have to do. That was the answer there. So they said a flower bed is in the shape of an isosceles triangle. Oh, wait. Oh, wait. Oh, wait. Oh, no, it's not. Okay, sorry. It's in the shape of an isosceles triangle that has a base of 8.4 meters. So they've given you the base of this triangle, right? Which is quite nice of them. So there is the base of the triangle. And the perpendicular height, guys, they've also given you that. You don't have to calculate that. 4.2. So are we able to visualize that, guys? Can you imagine like a flower bed that's in the shape of a triangle? Bit odd, hey? I don't think that usually happens, but that is what we're talking about. The base of the triangle of this flower bed is 8.4 and the perpendicular height is 4.3. Then we say the existing soil is unsuitable for planting and must be dug out to a depth of 0.75 meters. So guys, if you have a flower bed, right, the soil that we're taking out, that's volume, right? Because that soil, that amount of soil that was in that flower bed, that was the capacity of it, right? That's the amount of soil that was in there. And we know that that is volume. So they're asking for volume here without saying the word volume, right? So you need to be able to interpret that, right? How much soil must be dug out? That is the volume that we're asking for, okay? But now this depth of 0.75 meters. If you're thinking of the flower bed, it's in the shape of a triangle, right? So the triangle, the depth of the soil that must be dug out, that's like the height of the box, the height of the prism, the height of the soil that must be taken off. All right, so this depth that they've given us here, this is actually the height of, I'm going to put box in, what are these things, quotation marks. It's not actually a box, but that's, I think it helps to think of it in that way. Okay, so guys, here they've given us the base of the triangle, the perpendicular height of the triangle, and the height of the prism, that depth of soil that must be taken off. Okay, so all the information is actually given. You just needed to figure out that they're asking for volume. All right. So that was the answer there. Did anyone get this answer, guys? 13,3. Okay, good. Those of you that didn't, make sure that you understand where you went wrong. Okay, maybe you misunderstood the question, which is fine. But guys, you can do something like this in a history exam. All right, we're there. Describing a situation, and they're not telling you in words necessarily find the volume. But you must understand, if you're digging out soil, that is the soil that was in there, right? So that's what it's about. Yes. Oh, for the answer. I think it would probably be 3. Yeah. So 1 mark for understanding of the dead volume, 1 mark for all the values in the mark for R. Yeah. What do you mean? At the end? Yeah. You can if you want to. That's not fine, as long as you have the volume. Okay, final number 5, guys. Number 6, I think, was a bit easier, but again, they were not saying that, they were not asking for the volume, right? They were asking now how much concrete was used to make up the slab, right? The concrete base of the statue is in the shape of a triangular prism. The base of the triangle is 1.5 meters. Again, they're giving us the base of the triangle, and they're giving us the perpendicular height of the triangle. And then he's saying the height of the prism, they even use the word height of the prism, is 0.75. Now, guys, you need to understand, if they're asking for how many cubic meters of concrete does the builder use to make the slab? But guys, I guess the slab isn't hollow on the inside, right? It's the whole shape is filled with concrete. So that's why we're doing volume here. Okay. Because it's all the concrete that can go into that shape. The concrete that shape can hold, if you want to look at it in that way. Okay, so again, it's volume, half base times perpendicular height times the triangle times height of the prism. And then you just type that into the calculator. Any questions, guys? Okay, we are not actually moving on to surface area yet today. We're going to do that tomorrow. And then we're done with this chapter, hey? Yes, Frankie? Are we all done with number 6, guys? Can I move back? Okay, 1 second. I'm just going to bring up some pictures from the that are on the Google Classroom in those notes. Guys, remember we've done area of shapes with the part taken off, right? Now we're going to look at volume of shapes with the part taken off. It's very similar to the area that questions that we've done. Then you're done. What did you ask for, Frankie? Or just for me? Oh, guys, actually, before we do that, I just have 2 questions here that I want you to do quickly. None of these questions that we've done now had anything to do with cylinders, hey? But we do actually have to know how to find the volume of a cylinder. So I'm just going to put 2 pictures on the board for you. You can write underneath this exercise and then cylinder. Okay, because there were no cylinders here. Guys, we wrote down the formula for cylinders, right? Can you find that quickly? It was pi radius squared times pi of the cylinder. Now, guys, again, if the cylinder is going like this, right, then the height is going to be this, the distance between the 2 circles. Okay, so if you are given a shape that looks like this, you'll see the first one actually looks like this, and you're not sure about what the height of the box is, right? Because it kind of looks like this is the height. The height is always the distance between the 2 circles. So the triangular prism, distance between the 2 triangles. Cylinder, distance between the 2 circles. Okay, that helps. Thank you, that. Yes. All right, there you go, guys. There are 2 that I would like to define the volume for quickly. Using that formula that we wrote down on Monday, if you forgot, you can go look at your notes. It should be in your book. It's area of the base of the circle times the height of the whole one. Got it, yeah. Number one, this is five. To that, and I'm gonna show you. So, that's that one. Just use it in your home. And then I'll know that that's the radius. Guys, let's do to 3 decimal places for this one. It doesn't say there, so I'm telling you 3 decimals, please. Or convert it. What do you mean? It's fine, but I mean, Three. You guys have answers yet? Okay, let's take a look. So guys, in this case with these two, they were just straightforward cylinders. There was nothing funny about it. The only thing that was maybe a little bit funny is that in the first one they gave you the diameter of the ring. So you have to halve this to get the radius first. Okay, so what's half of 4? 2. Right, so in your formula you just need to make sure you don't have to write this first bit, guys. This is just explaining why I'm using 2 there and not 4. Now the formula works with radius, so it's giving you the diameter of that to get your radius. The pi times radius squared times the height, you type that into the calculator, you get your answer. Okay, next one. In the next one, you're just gonna have to do any halving, alright? The game's correct. Put in the formula and get on. Right. Any questions? Guys, are we fine? Okay, let's look at what happens if you have a part cut out of a shape. I don't really. Oh, sorry, that's frozen. Let's look at that shape there. So that looks like a V shape, but actually, if we're thinking in terms of our shapes that we've done, it is a triangular prism, okay? With a smaller triangular prism cut off. See that? Big triangular prism with a smaller one cut off. So that's for the areas when we had like a shape with the part taken off. We did the area of the big shape and then minus the area of the part that's been taken off. Okay? So what we'll do in this case is we will do the volume, I'll take the volume from, right? We'll find the volume of the big triangular prism. Now they see, let's take a look here. What is the base of this big triangular prism, right? 7, right? So 7 triangles. And the perpendicular height is 12. It's showing us there, hey? 12. I'm looking at the triangle on its own first. The base of the big triangle is 7, shown there, and the perpendicular height of the big triangle is 12. Okay? And then what is the height of this whole shape, this actual box? What do we think? 5. Okay, the distance between the two triangles. So we have a triangle at the front and one at the back. So the capital H for this one is going to be 5. We will write it down as now. So they go together into 6, and you guys know I prefer one line. Okay, you can have it. Then we have to minus the volume of the smaller one. Alright, what is the base of the small triangle? 3, right? So the particular height of the small triangle is 8. Right? Let's try that together. That is 8. And then it has the same height, right? That's the same distance between the front triangle and the back one. Okay, which was 5 centimeters. So guys, we are going to write that down quickly. We're not going to draw this picture, hey? No. I'm not going to draw this picture. I wonder, when I give you guys work to do, I'll quickly go print this page for you, okay? And then you can just stick the triangle, the picture in. So let's just on the next page or wherever you have space. This is going to be difficult now. Let me just take a picture quickly of this. Okay, let's focus. Volume of shapes that are not whole. Okay, that's the heading in the note on Google Classroom as well. So guys, let's do the working on this side, and then when I bring you the picture, you can stick it in next to it. Okay, is that fine with everybody? Do the working, and then I'm going to print the picture. Okay, so I'm going to write here volume of, let's just say V shape. Remember, to get the volume of that V shape, we said we're going to take the volume of the big triangular prism minus the volume of the small triangular prism. Okay, so I'm going to write that out in the words, guys. If you're doing an exercise or test for exam, you don't have to write it off. Okay, this is the first example. I am going to write that down. volume of big, let's just do a triangle and then write prism, minus volume of small triangle, the triangular, and then prism there. Okay, just like that. So guys, just on the side, I'm just going to write in a different color. Remember the volume of a triangular prism, just the formula. This is the formula that we're going to use is half base times height of the triangle times height of the actual prism. Okay, just a reminder, that's the formula that we're using. And all of the values were given, guys. The difficult thing about this section or these types of questions is figuring out what dimensions are for the big one and which dimensions are for the small one. Okay, so yeah, they did actually give us all of those values. We just needed to figure out what was what. Let's see, I took a picture of it now on my phone. Let's see if it actually shows up nicely. Here we go. Okay, that's the shape that we're looking at. Remember, for the big triangular prism, the base of that triangle was, what is that? That's a 7 at the top. Okay, so we're going to do half times 7 times the perpendicular height, which is 12, times the height of the actual prism, right, which was 5. So guys, when you're doing this all in one line, do brackets, okay, because we're going to do half times 7 times 12 times 5, and then close bracket. So we're mixing operations now, right? We're timing to get the volume, but then we're also minus it. Okay, so it's good if you're using brackets, right? Minus the volume of the small triangular prism, which I'll show you now again. Again, half times. Let's see what the base of the small triangular prism was. 3, hey? It's that gap there that I'm looking at. That's the small triangular prism. So the base was 3, the perpendicular height of the one that's been taken out was 8. And the actual height of that part that's been taken out was also 5, right? Which they gave us there at the bottom. Okay, so it's half times 3 times 8 times 5 again. Now you'll have to type all of that into your calculator, guys, exactly in the way that it's written there, with your brackets and everything. And the answer is actually a nice round number for change, 150. And what was the centimeters? Am I right? Let's see, I can't remember now. Centimeters, yes. 150 centimeters cubed. Okay, guys, I'm going to give you another one to do now that is exactly like this, from the exact same shape. They just have given different dimensions there. It's written in a slightly different way. So this one is, you can just make a new little heading, exercise 17.2. And I'll put it on the board just now so you can see the picture. On page 205, it's the same exercise that you had some homework on. But I would like you to do number 4C now for this one. You did 4A and B, right? And then there's another exercise. Let me just check if I will print for you, I think. Yes, no, yeah. Okay, guys, are you ready? I'm going to put the picture on the board. Just make sure that you've written that down. Because you can't see the exercise number on the, you won't see it on the board now. Okay, do that, and let's see if I do that. Can you guys read those values? Yes. I don't know where my board pen is. It's disappeared. Guys, if the two together are 5, and then 2 lines, 2 lines, 2 lines. All three of these start with that's the obvious. I think this is 30, 5 is 13, what's 13? 13 is over here. Okay, so they just double up on the thing here. So it's on plus, so don't worry about that. The 13. They just started acting as the 13 and that's 13 because of high ticket time. Like on the side, it kind of looks like it's that and then a little bit. Okay, but the 13 is actually that much weight. So 5, are we fine? Sorry, I can't write it on the board now. I don't know where my pen went. Okay, I'm going to print this stuff for you very quickly, guys. When I get back, you need to have finished this question. And then I'm going to give you another exercise with 2 more questions on. Yeah. Okay. It's very helpful of you.